All right, let's look at the second half of our sample test, starting with number 14. So for 14a, they told us to simplify the square root of 8 over 10. So first off, 8 over 10 would simplify down to 4/5. I can't simplify that any further, so let's break that apart into two separate radicals. So I have the square root of 4 over the square root of 5. And then the square root of 4, of course, is 2. I can't do anything with the square root of 5, though, and I'm not allowed to leave a radical in my denominator. So I'm going to multiply by the square root of 5, and what I do to the bottom, I also have to do that same thing to the top. So I'm going to have 2 times the square root of 5 in the numerator, and then square root of 5 times square root of 5 is square root of 25, or 5 in my denominator, and that's my answer. All right, if we look at the next one, so we've got the square root of 49 and 81, so I'm going to combine those. And then I'm also going to combine my x's. So the square root of x cubed, x to the 5th over x cubed. So of course, square root of 49 is 7 and square root of 81 is 9. When you have your bases are the same and you're dividing, remember you subtract your exponents. So I'm going to say 5 minus 2 and I'm going to get x squared. And then the square root of x squared, your square root and your square cancel each other out. You also could think of it as x times x, that when you have a pair, you can take one out from under the square. So I could take out an x. All right, so this x is over 1, so you could leave this as 7/9 times x, or you could say 7 times x in the numerator and 9 times 1 in the denominator, and write it 7x over 9. All right, then for C, I don't just have a singular radical in my denominator like we did up here with just the square root of 5. It's not just the square root of 6. It's being added or subtracted to something else. So I'm going to need to do something different. I'm going to need to multiply by the conjugate. So the conjugate, remember, is the exact same numbers, just the opposite sign in between. So I'm going to multiply the denominator by 2 plus the square root of 6. And what I do to the bottom, I also have to do to the top. All right, so in my numerator, I've got 5 times 2 plus the square root of 6. And in my denominator, we're going to FOIL. So 2 times 2 is 4. And then 2 times a positive square root of 6. And then 2 times a negative square root of 6. And then negative square root of 6 times positive square root of 6. So negative times positive is negative. And square root of 6 times square root of 6 is square root of 36, or 6. All right, so our goal was for these middle pieces to cancel each other out, and they do. And I'm left with 4 minus 6 in my denominator, so negative 2. Now, I cannot cancel this 2 with this 2. Remember, you can't cancel things that are being added and subtracted to something else. So if this had been like a 4 out here, then yes, I could have canceled that 4 with this 2 because those things were being multiplied. As it is, since 5 and 2 won't simplify down, I can't simplify any further, so I can leave my answer like this. If you'd rather distribute your 5, you're welcome to do that as well. All right, then 27 to the 2/3, when you have a fraction as your exponent, your numerator is going to be your exponent and the denominator is going to be your index, the thing that tells you you have a cube root. Remember, there is not an order of operations here. You do not have to square 27 first. So it's a whole lot easier to do the cube root of 27 first. So the cube root of 27 would be 3, and that leaves me with just 3 squared, and then 3 squared is 9. All right, then we move to section 1.4, which was our polynomials. So if I wanted to add two polynomials, when you're adding, the addition isn't going to change anything that comes after it, so we can just combine like terms. So 3x squared and 2x squared are like terms, so that's going to give us 5x squared. And then 2x and negative 1x are like terms, that gives us 1x. And then we have our constant that didn't have anything else to combine with. All right, if we're subtracting, however, that subtraction sign is going to change every sign that comes after it. So you'll notice subtraction is adding the opposite. So we're going to go through, and this is going to become a negative 2, a positive x, and a negative 3. I'm sorry, a positive 3. So we changed every sign. So now if we combine like terms, 3x squared minus 2x squared is 1x squared. 2x plus 1x is 3x. And the only constant I had was the positive 3. All right, so then we looked at multiplying polynomials. So when we multiply, we FOIL. When we have a binomial times a binomial. So I'm going to do first, 3x times 2x is 6x squared. Outer, 3x times 5 is 15x. Enter negative 4 times 2x is negative 8x. And last, negative 4 times 5 is negative 20. Then 15x and the negative 8x are like terms that I can combine to get 7x. All right, if I have 2x minus 5 squared, remember that I can't just like square that first one and square that last one. What that literally means is 2x minus 5 times 2x minus 5, and I need to FOIL. So 2x times 2x would give me 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. And negative 5 times negative 5 is positive 25. So negative 10x and negative 10x are like terms. Let's combine those to be negative 20x, and that gives us our answer. All right, then let's look at C. All right, so for C, I have a binomial times a trinomial. So you literally can put your finger over this negative b and just look at it as I'm going to go through and take a times a squared is a cubed. A times ab is a squared b. A times b squared is ab squared. All right, now put your finger over the a. Now we're just going to go through and take the negative b and multiply it times each of those. So negative b times a squared is negative a squared b. Negative b times ab is negative ab squared. And then negative b times positive b squared is negative b cubed. So for like terms, you can see the a squared b and the negative a squared b are like terms. When we combine them, they cancel each other out. And ab squared minus ab squared, those are like terms, they cancel each other out. So that just leaves me with a cubed minus b cubed. And what we just created there was our difference of cubes formula that we're going to use down here in just a second. All right, remember that when you are factoring, so number 17, they ask us to factor. Remember that when you're factoring, first you're going to take out your greatest common factor, and then you're going to look to see how many terms you have. So because we only have 2 terms, that could be a difference of squares, a difference of cubes, or a sum of cubes. So since it's a difference, and these are both squares, that's a difference of squares. So x squared would have to be x times x. And 100 would have to be 10 times 10 because it has to be a perfect square. You have to be multiplying that number times itself to get this. And remember with the different squares, it's always one sign plus and one sign minus. In either order, you could do plus minus or you could do minus plus. All right, then for B, we have a difference of cubes. So here's our difference of cubes formula right here. So we do need to know that formula. And if you'll notice, I'm going to put x in the place of a, and I'm trying to figure out what cubed is 27. Well, 3 cubed is 27, so I'm going to put 3 in the place of b because 3 cubed would be 27. So x in for a, I'm going to come over here and put x in for this a, and then 3 in for b, put 3 in for this b. So x in for this a, 3 in for this b, and x in for this a. And then 3 in for this b, so 3 squared would be 9, and that would be my answer. All right, a sum of cubes works the exact same way. The only difference is just the signs. So remember, SOAP tells us what our signs will be, so it's going to be same, and then opposite of what we started with, and then always positive. So you can see that up here, that it was the same sign, and then the opposite sign, and the last one's always positive. So if you'll notice, we get the exact same answer here. It's just these 2 signs are changed because of the same opposite of our same opposite, always positive for our formula. All right, then we learned that if you have 4 terms, you can factor by grouping. So I'm going to group my first 2 terms, and I'm going to group my last 2 terms. And then I'm going to see what greatest common factor I can take out of these first 2 terms. So if you'll notice, I could take out an x squared. So if I take an x squared out of x cubed, that's like x squared times what is x cubed? X squared times what is negative 3x squared. All right, then over here, I could take out a 4. So 4 times what is 4x? And 4 times what is negative 12. In order to factor by grouping, these have to be the same, and they are. So I'm going to take that common factor, that x minus 3, I'm going to take it out, and then you can put your finger over this x minus 3 and this x minus 3 and see what you have left, and what you have left is x squared plus 4, so that's your other factor. All right, so we've looked at 2 terms and we've looked at 4 terms. Now let's look at what do we do if we have 3 terms, right? So if we have 3 terms, First off, the first type of problems that we see are when our leading coefficient is 1. So for E and F, our leading coefficient is 1. So I'm going to find the factors of 12. So that's just 1 times what is 12? 12. 2 times what is 12? 6. 3 times what is 12? 4. 4 times what is 12? 3. But as soon as it starts repeating, I can quit because I know I've found all the factors. Because this is a plus sign right here, then I'm going to find, remember when this is plus, we're going to think sum same. So I'm going to find the sum of these numbers. So 1 and 12 was 13, 2 and 6 was 8, 3 and 4 was 7. So what I was looking for was two things that would multiply to be 12, which all of these do, but that would add to be -8. And so obviously it's going to be 2 and 6. But to get, remember that if this is the plus sign right here, we think sum same. That means our signs are going to be the same. They're either both positive or both negative. And so for this one, you'll notice that if it's going to add up to be a -8, it would have to be a -2 and a -6, because a +2 and a +6 would be a +8. So they're also going to be the same as the sign of this middle term. All right, what if instead this was a minus sign? If this is a minus sign, we're going to think difference. So I'd start the same way. I'd get all those same factors of 12, but this time I would find the difference between them. So 12 minus 1 is 11, 6 minus 2 is 4, and 4 minus 3 is 1. And so what I'm looking for is the 11, so there's my pair right there. So remember when you see this, we think difference, we just found the difference right there, and different. One of my signs is going to be positive and one of my signs is going to be negative. To figure out which one it is, I need to figure out if I add these, am I going to get -11? I would have to have a -12 and a +1 to get -11. If it was a +12 and a -1, I'd get +11. Also remember that I need the larger number to have the same sign as that middle term, so that might be an easy way for you to figure out which one's positive and which one's negative. All right, let's skip G for just a second and go to H. When we first look at H, because it's got this number out in front, we think, oh, that's going to be one of those really hard ones. I'm going to have to do the AC method on that. But if you'll notice, our very first step in factoring is to always take out the greatest common factor. If you'll notice, you could take out a greatest common factor on this. So if I take out that 6, now what I have left to factor is a leading coefficient of 1. So you can just put your finger over the 6 for a second and ignore it. All I need to do is just factor this guy, all right? So I know that x squared is going to be x times x. I also know that because this is minus, I know that my signs are going to be different. So one's going to be positive and one's going to be negative. And the only things that can multiply to be 2 are 1 and 2. So that's my only option. So all I need to do is figure out, is it a +1 and a -2, or is it a +2 and a -1? So to get a -1, I need the larger number to be negative. All right, so then if we go back to G, there is no greatest common factor to take out of this. So I am going to need to do the AC method on this one. So you could either do trial and error in trying to factor this down, or you can take A, 6 times C, 12, and get 72. So we're going to find all the factors of 72. So that's 1 times what? 72. 2 times what? 36. 3 times what? 24. 4 times what? 18. 5 doesn't work. 6 times what is 12. 7 doesn't work. 8 times what is 9. And then when we get to 9, it starts repeating, so we know we've got them all. So since this is a minus sign right here, I'm going to think difference. And so I'm going to find the difference of all of these. And so there it is right there. There's the one that I want. I want 8 and 9. Now, in order to get a -1, I would need a +8 and a -9. So +8 and -9. So what I'm going to do is I'm going to replace that -1x with a +8x and a -9x, because those two things add up to be the same thing. I'm just substituting an equal for an equal. And now I have 4 terms, so I can factor by grouping. So I'm going to group my first 2 terms. I could take a 2x out of them and be left with 3x plus 4. Then for my last 2 terms, I'm going to take out a -3 so that this matches. If I took out a +3, it wouldn't match. All right, so since 3x plus 4 is my common factor, I can take it out, put your finger over both of those, and what you have left is 2x minus 3. That's your other factor, and so that's how we factor with the AC method. You will be able to use one of the little calculators that's the add, subtract, multiply, divide guys to help you be able to do this type of thing.